Trust it!
Hey everybody, Dr. O. In this video I want to talk about the BSL levels or biosafety levels. So the reason this is important in microbiology is because it determines what kind of precautions we need to take if we're working with certain microbes. So obviously in the labs that I teach we hang around in the BSL-1 and occasionally into the BSL-2 level, but I actually want to walk through each of these levels here and give you a few more examples than the book does as far as the different levels. But as you can see here, BSL-1 is going to be your lowest risk microbes. You really don't need to take any special precautions. For most of these labs we don't even have to require gloves and eye protection, these kind of things. Obviously those are always a smart idea. And as we travel, BSL-2 would be the highest level that we ever work with in our lab, BSL-3, and then BSL-4 is going to be where you have to take super special precautions. So let's go ahead and walk through each of these. So I'll just read this. BSL-1, microbes are not known to cause disease in healthy hosts and pose minimal risk to workers and the environment. So the example here is the non-pathogenic strains of E. coli. So obviously E. coli 0157H7 or the other enterohemorrhagic strains of E. coli would be much higher up on the list, but these are the ones that you really don't need to be super concerned with. Now, I'm still always worried about the potential for what are called opportunistic pathogens. So let's say you have cuts on your hands, we're going to take special precautions there. If you're immunocompromised, we'll take special precautions there, but in general, these are pretty safe. A couple more examples, because this is how I like to work. I like to actually expose you to, pun intended, I guess, low-level BSL-1 organisms that can still teach you about the much more dangerous strains. So obviously we can learn a lot about the more dangerous strains of E. coli by looking at the non-pathogenic strains. Same thing with Mycobacterium smegmatis. We usually use that organism instead of obviously working with its cousin Mycobacterium tuberculosis. So we can learn about the acid-fast organisms that way. And then Bacillus subtilis would be a relative of Bacillus anthracis, which causes anthrax, but obviously Bacillus subtilis is a soil organism. It's actually found in a lot of probiotics, so instead of being dangerous, it actually appears to be a beneficial organism. So those are the kind of organisms we work with in the lab to make sure that you're safe. I'm much more concerned about your safety than anything. All right, BSL-2, microbes are typically indigenous and are associated with diseases of varying severity. They pose moderate risk to workers in the environment. So you see Staphylococcus aureus as an example here. These are much safer than the higher level organisms, but you still do need to be careful with them. I'll give you a couple of examples of BSL-2 organisms. Streptococcus pneumonia, which is still the leading cause of community-acquired pneumonia on the planet. It kills somewhere in the neighborhood of 1.4 to 1.5 million humans a year. So this organism is no joke, but for healthy people being super cautious in a laboratory environment, it doesn't appear to be that big of a threat. Another good example is Enterococcus faecalis. This is becoming a much more serious nosocomial or healthcare associated infection, but working in the lab, it's still classified as the BSL-2 level. Okay, BSL-3 organisms, biosafety level 3, microbes are indigenous or exotic and cause serious or potentially lethal diseases through respiratory transmission. So obviously you need to be super careful here. Taking extra precautions to make sure you don't breathe them in. But these are generally diseases where there are treatments available, there are vaccines, this type of thing. So the example here is Mycobacterium tuberculosis. Another example of a BSL-3 organism would be Yersinia pestis, which is the cause of the plague, the Black Death. Nobody wants to get that. All right, your BSL-4 organisms, microbes are dangerous and exotic, posing a high risk of aerosol-transmitted infections, which are frequently fatal without treatment or vaccines. Few labs are at this level, so like we'll never be looking at any of these organisms. So the examples they give here are Ebola and Marburg, which I think Marburg is actually more dangerous than Ebola, as crazy as it is to say. The Lassa virus would be a BSL-4 organism. The various variola virus, which causes smallpox, would be a BSL-4 organism. So that's actually kind of an interesting one because it is a BSL-4 organism, but not all BSL-4 labs get to work with it. There are just a handful of labs on the entire planet in Russia and here in the US that get to work with smallpox. So, all right, or the causative agent of smallpox. So those are your BSL or biosafety levels for microbiology. Have a wonderful day. Be blessed.